Yeah, good evening, everyone. So let's start off. Yeah, comes on everyone. So last thing we have done the method 2, the power method. The power method is quite useful, when strings are involved. But the problem comes, when if the motion is happening because of other forces, we start having problems. So this method 3 is not an official thing. This is actually same as a method 1. So let's see how that works. Others, do keep your cams on. Now, let's see what is this. Now this thing kind of looks a little, kiddish, but it kind of works. So let's see what it is. So if there are two independent events, E1 and E2 create effect 1 and effect 2. When both the events happen at the same time, we get effect 1 plus 2. This is called the principle of superposition. Quite an important principle in physics. We use this a lot. And actually, we have already used this. We just didn't, maybe you guys didn't realize it. Remember in projectile motion, how did we study projectile motion? We said the motion is split along two perpendicular directions along x and y, and then we studied x separately, y separately, and we added the resultant, isn't it? So it is the same thing here. So this is what it means, because the direction in x and y is independent of each other. So we have studied x separately, y separately, and we simply added the motion there, and we got this example. Let's say we have a body here, and you're exerting a force F1, and let's say this thing goes A1 I cap. If you have a body here, and if you're exerting force F2, and this is going A2 J cap. Now, if you combine both the forces at the same time, F1 and F2, you will go somewhat like this. That would be A1 I cap plus A2 J cap. This comes in a lot of places. Ali, I'll be removing you from the classroom in a minute. Right? I don't know why I should threaten you guys to keep your cams on. Don't make me an evil gangster. Let me be an innocent physics teacher. Right? There are 4 people missing. Why people are absent? Maulika is not well, but other 3 people are absent. In case someone has an illusion, online class, chalta hai, we'll chill out. You are definitely in a wrong place. If that's what you're expecting, you should leave the class and join somewhere else. I'm expecting everyone is here to crack the advanced exam, so I expect that kind of discipline and sincerity. You don't need to have a super IQ to crack an exam like advanced, or even to have an awesome life, but you need to have a certain discipline and commitment. Now, not only this thing, this principle of superposition, right? Just to an example, I can even use this in circuits. For example, let's say if you have a battery here, and if you have a resistor, and let's say you have one more battery here, and a resistor like this. Let's say this is battery 1 and battery 2. So if you had only battery 1, we will see this in current electricity, but this idea, right, doesn't just stop at motion. If you had only battery 1, or if you had only battery 2, and let's say this battery 1 is creating a current I1 here, and this battery 2 is creating current I2 here. when both the batteries are there, the current would be I1 minus I2 because both are opposite direction. You're getting this principle of superposition? This thing doesn't just stop at motion, it just even goes to the batteries also. So if only battery 1 had been there and the current would have been I1 to the right side, if only battery 2 had been there and the current would have been I2 to the left side, if both the batteries are there, the current here would have been I1 minus I2. So this is what we call as principle of superposition. So as long as you have two independent events, whenever you add them, the effect will be the resultant of both the effects. I hope everyone is clear with the principle of superposition. Clear? So now how do we use this? Any doubts on this page? Units and dimensions paper is online. Huh? The test will be available till Tuesday night, so make sure to give it. This time paper pattern I changed it a bit because I observed most of you having problem in advanced more than one choice questions. So 15 single choice, 5 more than one choice, and 5 integers. So we will have a different pattern henceforth. So this will get you used to that more than one choice questions. And you have partial marking for more than one choice. So partial marking meaning, let's say if you have options A, B, C, D, and let's say answers are A, B, C. But if you just mark A and B, you get 1 mark and 1 mark. If you mark all three, you will get 4 marks. But if you mark A, B, and D, you get a -1. I hope the marking scheme is clear. This is the actual marking scheme of JEE. So as long as you don't mark a wrong answer, you get some marks. The moment you mark a wrong answer, you get a -1. So there is a partial marking for that. So do be careful while attempting. And integers and single choices as usual, negative markings are there. So that will be the pattern this time. Units and dimensions. So do give it a try. I did include some weird questions also, 4 or 5. Let's see how you guys do this. You will learn a lot from the paper. So how do we use this thing? The logic here is, now this is kind of obvious, but let's observe this. So if you have two blocks here, A and B, we know here the blocks A and B will move at the same time. A and B will move at the same time. So what we will do, let the blocks move one at a time. Because if A and go both at the same time, or A goes first and B goes second, it shouldn't affect the final result. Let the blocks move one at a time. So this is what we do. First, let only A go up. I know that's not possible technically, but you can always, imagine that. So if A goes up, what will happen? The string will actually become loose like this. So when this thing goes up by X, we have the loose string. So this method is more of visualization than actually a proper physics thing. Now let B also go up. I know that is not possible. Both can't go up, but let's see what happens. So this thing has gone up by X and this thing has gone up by Y. So the total loose string is X plus Y. But I know in a system, you can't have a loose string. The string can never be loose. So end of the day, we are actually using method 1 only. The length of the string is constant. So since we got X plus Y is equal to 0, differentiate. So we end up with dx by dt, that will be VA bar plus VB bar is equal to 0. We get VA bar is equal to minus VB bar. So what the method simply says is, whenever the blocks move, whatever loose string or the string that becomes tight, that can't exist. The length of the string has to be constant. So it's kind of pretty basic thing. In this problem, it is pretty basic. It is obvious when A goes up, B comes down. But this idea, the string is getting loose and tight is important. We'll see some problems where it helps a lot. Have a look at this. Let me take one more example like this. Any doubts on this? Venkatesh? Rehan? Arjun? Abhinav? Anusha? So far clear?
Yes, sir.
Ali? Aryan? Clear? Palaksh? Swastika? Easy, straightforward, kind of obvious kind of thing this is. Can I go ahead? No. Using the same thing, if I take one more example, let's say we have a block A here. We have a pulley here and this is fixed. And this is B here. Now, if I move A by X, can you tell me how much will B move? How much will B move? Your answers shall type to the co-host here, don't forget. 2x, right? Meaning if you use the unit, that thing, the force method, the power method, you have got it. But let's try to visualize this. Listen carefully. When this goes X forward, see what happens. This will be at the same place. This pulley would have come somewhere here. And this block A would have come somewhere here. See what happens. So this has gone X forward. So that means the pulley also center to center would have gone X forward. Now think about it. When it has gone X forward, what happened to this string here and this string here? This string here, the green thing which is shaded here, this also will go X forward and this also will go X forward. Isn't this the loose string? Able to visualize that? Whenever the pulley goes forward by X, it is going to release the string on the top, on the bottom by X and by X. Now tell me one thing, where will all this loose string go? Someone has to take this. A, B will take that. So this will go down by 2x. I hope everyone is able to visualize this. Whenever the pulley will go forward by X, it is going to, if you observe here, this part of the string was missing here. This string and this string was missing. So that string should have gone somewhere. And the only person who can take that is B. Please check out this. If you understood this logic, I think your method 3 is pretty solid. We can do some decent problems. So let's call this pulley 1 here. This is pulley 2. 2 is fixed anyway. And pulley 1 moves by X to right. The string becomes loose by 2x. And since the length of the string can't, then this is taken by B. So just remember this. If there are only strings involved, just use method 3. That is always safe for you. You'll not do any mistakes. If there are only strings, meaning there's no normal reaction, friction, all these kind of things are missing. If there are only strings involved between the blocks, use method 2. So let's see some questions. We can apply this on one system. What do you mean by that exactly, Udin? If you're saying there are multiple pulleys.
Sir, if the string is connected to different systems, like different
For
pulleys.
example, you can do that, but बहुत complex हो जाएगा. For example, say. For example, if you take this problem here, if I say this goes up by X, so यहाँ पे X lose होगा, यहाँ पे X lose होगा, right? when this gets loose by x, meaning the pulley will come down by x. So यहाँ पे 2x lose होगा, and this will be x, so this will be x. So total this will go 3x. You can apply, but quite complex. That's what I'm suggesting. Don't do this, for if there are only strings involved, use the power method, T1 V1 plus T2 V2. You can apply, but you have to really think about it. Clear? So let's say a question on this. We have a block here. We have a system of this sort. This is A and this is B. And here A is going with speed U. And this is a fixed wall. Find the velocity of B. Now, just give a little context what is happening here. Observe this thing. Because of this B ka weight, this will come down. When this comes down, this will pull the string, this will pull the string, this will pull the string. Because the string is pulling, A will go to the front. No? I hope everyone able to visualize the diagram. How will the diagram look like? The A will come forward like this, and the B will actually come down like this. So B is coming down and A is going forward. The wall will be like this. This is how the diagram is moving. So if A is going with speed U, find the speed of velocity of B. Just to give a little context here, the normal reaction between A and B transfers energy. So method 2 gives you incomplete answers. It gives you some part, but to you, Anika, you are right. Ronak, you are, like I said, incomplete. Aditya, incomplete. If you use the power method, you'll get an incomplete answer here. Let me help you with this one. And I'll give you more like this. Listen. Again, the idea is the same. Move the block A by X, and see what happens. So if this thing goes a little forward, the pulley becomes like this. This pulley is here. Observe the diagram, what happened. So when the A has gone forward here by X, this pulley also here, if you observe, it has gone forward. So what happened to this string here? This part here, X, and this part here, X. The string got loose at 2 points, right? Isn't it? The upper part got loose by X and the bottom part got loose by X. On top of it, something more happened. The B also went forward by X. Can you see what happened? The B actually has two motions. B is going forward also and B is coming down also. Are you guys able to visualize this? So when A goes forward, so this is the loose string. We have two loose strings. On top of it, B is also being pushed forward. When A moves towards left, string becomes loose by 2x. And B is also pushed by X forward. And B comes down by 2x. plus due to the normal reaction or due to being in contact, it is also pushed forward by x. Due to being in contact, it is pushed by x forward. That means this block B here will go 2u downward and will also go u forward. So velocity of B will be u I cap minus 2u j cap. Check. Clear with this? So you know how is the motion of this B actually? The B is actually going at an angle. I'll just show the diagram again. I'll just draw a big one for our understanding. I am drawing the diagram in the red. Red is the final diagram. So this block has gone like this. This pulley has come like this. And the B has traveled like this. So the B is actually traveling this way. This is the velocity of B, where this velocity is u and this velocity is 2u. Able to visualize how B is traveling now? B is actually traveling at an angle theta. It is going along a diagonal. It is not coming down. It is not going right. Any doubts on this? And here you can clearly see this is the loose string. This is the loose string. And this is the loose string. Because there are two strings getting loose, right? Again, whenever it goes forward, देखो ना ऊपर का string भी loose हो रहा है, नीचे का भी string भी loose हो रहा है. Now where will all the string go? The only person who can take is B, right? Make sense? Is that convincing? All sure? Let's see one more like this. Any doubts on this? Please ask me. It's a good one. So these kind of problems, use method 3. You have to visualize whenever there's a contact and all. Let's see something similar but slightly more complex. This angle is theta. Velocity of A is u to the right. Find VB. Let's get this thing. This is a better version of the previous one. Now you have an incline also at an angle theta. Try. You got a minute or two. These problems, right? If you can think, it will take less than 30 seconds. If you can't figure out it, you'll get a lot of confusion. We'll wrap up with constraints today. After this, we'll do rigid body constraints. Try. Everyone should try. It's okay to get a wrong answer. Again, never get scared to get a wrong answer. Maximum, you'll scratch it on a paper. That is a good sign. Means you're trying. Don't blank out. Whatever you think you do, get a wrong answer. Totally acceptable. Physics, that's how we learn. You should never get scared of something which you're going to crack. You are going to crack the advanced exam, and don't get scared of the questions. Have that courage. Maximum, if it goes wrong, you will learn. You don't get it, I'm there. I'll teach you anyways. But try. You got a minute. Keep that in mind. I'm telling you again, what gets you into IIT is not your IQ. It is your hard work and attitude. Most people think it is hard work, but actually it is your attitude also. No, Palaksh, that's wrong. Anika, that is wrong. Aditya, you're right. Rehan, you're wrong. Aryan, wrong. You are incomplete on nah, Yasha, that is wrong. Incomplete answer. Try another 30-40 seconds. Minus n होना चाहिए. You would have got it right. I think it was minus n, you understood. Right, Yasha? See everyone. So when this guy forward by x, I'll just draw it in the same diagram. Let's say this thing has gone like this. Now, if you observe this, when it has gone forward, can you see? This part gets loose, this part gets loose, this, and this. There are total 5 strings that are getting loose. And this will remain constant only. It has just gone forward here. If you look at the diagram there, when it has gone forward, this length of the string does not change. The one in the green, that will remain same, that is not affected. So whenever this thing goes forward by x, you get 5x loose string. And someone has to take this. So the only one who can take this is B. B will go 5x down. On top of it, B is also going forward with the wedge because it is standing on it. If you observe, this is also x forward. So B would have gone x forward. And 5x because of the loose string. So B actually has 2 motions. U forward, 5u this way, and this is theta. So velocity of B will be, resolve the vectors u plus 5u cos theta I cap. And the vertical component is 5u sin theta j cap. So I just resolve the component. This is u and I resolved 5u into cos theta and 5u into sin theta. Please check. If they ask you for magnitude, square them and add them. So there are 2 things happening. Because you're in contact with that wedge, you will go forward by x. And because there are 5 strings getting loose, you will come down by 5x along the incline. So there are 2 motions there. This, if you try to use a method 2, you will get only the 5x ka part. You won't get that horizontal u ka part. So especially whenever you're in contact with some other body and you're moving with it, this would be a good way to use. You can figure it out, visualize. Clear? Let's see one more like this. Any doubts on this?
So won't the block eventually come to the foot of the...
Let's ignore that right now. Block will fly away, strings will get cut. I know what you're saying, physical situations, but let's not get into that. It's a long incline. Okay.
Yeah.
All clear with this?
Yes.
Yeah. There was one problem I was saying like that, and I said a stone is thrown into the air. After what time it comes back? Sir, a crow comes and catches the stone and goes away. Then what will happen? No, what? That is not what I was expecting, right? Next one. This is a good one, right? This again we will do later on, when we calculate forces and stuff. This is A, this is B. So in both the cases, A is going, let's say, this way, VA is U. A is going this way, VA is U. Find the velocity of B at this instant. Talk to you, pyro to you. I think I'm gonna show you all right. Let's see. First part, most of you got it right. I think second part, some of you are still thinking. The difference between 1 and 2 now. Did you ever observe this thing? I don't know whether you must have done it or not. You have your bag on and you're running behind a bus or a train. Ever did that? When you run that, what is the most irritating part? This is what happens. If you're like this and if you're running with a bag on, the bag literally becomes like this, isn't it? It's like your cape flying, like a Superman ka cape. So the moment you start running, this is what happened. The bag, which is like this, the moment you run, the bag kind of becomes like this. The bag will keep hitting you from the back. You're running, the bag is hitting from the back. Observed anytime? It's actually quite irritating. So you have to catch the bag and then run fast. The reason why this happens is the moment you go inertia, the moment the surface goes forward, there is no contact here. So this will just fly off in the air. That's it. And in the first case, in this case, you know what happens? Imagine you're keeping the bag in front of you and then you're running. Ye Mumbai mein hota hai. People keep the bag in the front and then run in front of the train. Meaning I saw first time actually Mumbai mein people keep the bag in the front. That was something which was completely different from me when I saw it the first time. And in a Mumbai local, if you get into a train with the bag behind, the people will just curse you. So because you can't control the bag, it can just hit anyone. But it is in the front of you, you can do something about it. So what happens here is when this guy goes forward, the pulley will come here. B will come here. You will clearly, you can see here. This part of the string was missing. This part of the string was missing, X. And also this thing has gone forward by X. And this part of the string was missing. So this thing has also come down by X. So the B here is traveling U to the right and u to the down. So velocity of B will be minus ui cap minus uj cap. Now the difference in the B part, the moment this guy goes a little forward, the B actually starts flying like this. It loses contact. It does not go with the A part. So that loose string ka part is still same. So this thing will come down by x, but there will be no horizontal displacement. B loses contact with A. That's the difference in this problem. So there is no horizontal velocity. So VB will be simply minus uj. Easy? There, that's the difference between both the problems. So that is the reason. See, I said at this instant, meaning that theta, na, this angle is almost negligible. If I give you after some time, I can't solve this problem because I don't know at what angle it is flying, how high it is going, a lot of information you need. So whenever they ask you this B part question, it will be always at this instant. Abhinav,
So can you explain the A1 again?
what happened? Which part you didn't understand?
So like its motion downwards.
You understood this thing?
Yeah, I got that one.
It is the same thing, right? If A goes forward, what will happen? If A goes to the left, B will come down and B will go left also.
Okay.
Because they can, what will happen to this loose string? That will make it go down.
Okay.
All clear with this?
Yes.
Clear? Let's see one more like this.
Sir,
Rehan.
so in the second part, eventually B will hit the A, right?
Eventually. That is the reason the question is at this instant. That eventual part we can't do. So we'll not get into that. We don't have data to do that. So always, whenever they ask you the second part of the question, they'll always ask you at this instant. Clear? Everyone? Easy? Got this? If you see these problems, right, you can't do with method 2 or method 1. You need to figure out, okay, this is what is happening. Let's see one more like this. Let's say A is going down with 2 meters per second. B is coming with 1 meter per second. Find velocity of C. This is a good one. Y root 3j to check the answer, even I'm not sure. 3 root 7. Now observe this thing. Now when this comes down by 2 meters in 1 second, let's see for 1 second. This will come down by how much? 2 meters. In 1 second, how much will this travel here? 1 meter. So you tell me how much string is getting loose or tight? This is pulling down by 2 meters and that is going forward by 1 meter. Just let's imagine a situation. You know, this is how it would look. You get a gap of 2 meters here. So this is A pulls the string down by, or you can say A tightens the string by 2 meters. And if you look at this thing, the B loses the string by 1 meter. B loosens the string by 1 meter every second. But we know the length of the string has to be constant. That means the C which is traveling here should be how much? The amount of string that is becoming tight should be equal to amount of string that is becoming loose. Do you agree with that? So whenever VC goes forward, it will loosen the string by VC. So this loosens the string by VC. So the loosened string per second, amount of string that is becoming loose should be equal to the string that is becoming tight because the total length is constant. You have to visualize this. So if you can clearly see here, how much should that be? So 2 meters per second, that is a string which is becoming tightened, is 1 meter per second. That is because of C plus VC. So V from here, we get VC is equal to 1 meter per second. But this is not the full answer. What is this? This is the velocity of C on the incline. So this guy is traveling here with 1 meter per second. But because you're on the wedge, you'll also travel 1 meter per second forward. So C is going along the incline with 1 meter per second. Because of that strinker motion. And 1 meter per second horizontally because it is in contact with the wedge. Is this making sense, everyone? Again, listen to this thing. Whenever A comes down, you know, if I just draw this diagram, A would come somewhere here. So यहाँ पे 2 meters का gap आया. Are you getting that? If that A comes down, you get a 2 meters ka gap. If this incline has gone forward like this 1 meter ka string will become loose. So you're getting 2 meters ka tight, you know, the gap is coming and 1 meter ka loose string is coming. So how much more string you need? You need 1 meter ka loose string, isn't it? Who can provide that? Only C can provide. That means C must have gone forward, releasing 1 meter ka string. So C is playing two roles. It is going along the incline. It is also going forward. So it is going at an angle like this. Please have a look at this.
Sir, won't it be like that previous question? I'm having a doubt.
Which one?
In the previous question, you said that B starts going at an angle. So here
B, yeah.
it won't be the same here.
We are assuming C is always in contact. Matlab, you're saying C will fly. There is a possibility. If B goes very fast, C can fly here also. But let's assume C is always in contact with wedge. There is a possibility. In this scenario, right? Because देखो ना, previous case में क्या हो गया ना? The only force is vertical, ना? But here what happened? This mg ka component can make it, you know, stick to the incline. What you're saying is true. There is a possibility it can fly. We will do that kind of questions also. What is the acceleration of the wedge if C loses contact? But let's assume there's a contact here. All clear with this? Please check it out. This problem is like just visualization. ऐसा हो रहा है तो ऐसा हो रहा है. It is like that sort. There is less of a physics and more of visualization. Answer is still not over. So what is C ka answer? So C is going this way with 1 meter per second. And C is also traveling with 1 meter per second. And the beach ka angle is 60 degree. So resultant would be velocity of C would be -1 minus cos 60 I cap and 1 sin 60 j cap minus 3/2 I cap plus √3/2 j cap. Check. So C is actually doing two things. It is going left with 1 and it is going along the incline with 1. All clear with this? Anyone not convinced with this, not clear, please ask. This is something which you need to think like, okay, aisa karna hai. If you see in the sheet which I given, there are 1 or 2 questions of this sort. There was a wedge like this, there was a block like this, and there was a B like this. It is going down. All 3 things were moving at the same time. Any doubts? All clear with this? Can I go ahead? Palaksh, Ali, clear? Udayan, clear, na? Vartika? Vastika, clear? Anika, got this? Going ahead, next part. So that's about the string constraints. So the main methods there. Next thing is a rigid body constraint. So what is this? First of all, what is a rigid body? The definition is pretty simple. So the rigid body is the distance between 2 points on a rigid body is constant. It looks a pretty simple definition, but it's a very powerful statement. Means if you take 2 points on a rigid body, do whatever you want, the distance, you cannot change the distance. And this will be the basis of rotational mechanics, the starting part. So the meaning of this statement, right? Think about it. No matter what you do, you can't change the distance between them. Matlab, the body cannot be deformed. You can't elongate or can't compress. No matter, even if you apply infinite force, you cannot deform the body. Body cannot be deformed. That is, cannot be elongated or compressed. And that's a very important idea there. And rigid bodies are hypothetical. They don't exist in nature. So in laws of motion, friction, all these chapters, right, we will deal with rigid bodies only. I think in center of mass and collisions, again, we will deal with bodies, which can compress a bit. So how do we use this concept that the distance can't change? So see, if you consider a rod, with ends A and B, with velocities VA bar and VB bar. So let's say this is point A, which is having velocity VA this way. This is point B and having velocity this way. These kind of velocities are possible. Whenever a body is rotating and translating, these kind of velocities you get. Ever played a pen game? When you hit your pen on the table, the pen rotates and goes forward. So in that kind of motion, you get velocities like this. So here, if I try to resolve these components, this is theta A and this is theta B. This component will be VA cos theta A. This component will be VA sin theta A. For today's class, we are more interested in the cos theta components. Sin theta components will be useful in circular motion. We will deal with them later on. V cos theta B and VB sin theta B. Now, think about the cases. Case 1. If VA cos theta A is greater than VB cos theta B. So, if the person in front of you is going faster than you, what will happen to the distance between both of you? If the guy in front of you is running faster than you, will the distance increase or decrease? Increase. So that means if VA becomes VA cos theta is greater than VB cos theta B, rod will elongate. Because A is going faster than B, the rod will stretch. Suppose if VA cos theta A is less than VB cos theta B, that means if the guy behind you is coming faster than you, then what will happen? Distance between will you decrease, the rod will compress. But you said it is a rigid body. The rigid body can't compress, can't elongate. What other option is left? They should be equal, right? Since rigid body cannot compress or elongate, you have only one option left. They have to be equal. That's why I said that statement is quite powerful. Distance remains constant. You can figure out a lot of stuff from there. Check out this page. This is the whole theory behind the rigid body constraint. So whenever two rigid bodies are in contact, since you can't compress them or elongate them, you don't have an option, but they have to have the velocities along that line should be same. So let me extend this for a body. Clear? Now, if I extend this concept here, can I turn the page? Everyone clear with this idea here? So if I extend the same thing for a bigger body, let's say component of velocities along the line joining should be same. Line joining 2 points must be same. That means you take any random rigid body, it doesn't matter. If this guy is A and this guy is B, and if you join the line A and B, let A go any way it wants. Let A go like this. This angle is theta A, and B go like this. And these kind of velocities are possible whenever a body rotates and translates. We will see that. So if you look at the components here, so VA cos theta A should be equal to VB cos theta B. The velocity components along the line should be same. So further extending this, if two surfaces are in contact, the velocity along the common normal must be same. Again, same reason. If it is not same, the body will either deform or compress. That's it. A rigid body, the whole story is that you can't compress, you can't deform. Just because of that one property, right? You get a lot of data from there. So if you have a sphere and a wedge like this is the common normal. Means the velocity of the wedge and the velocity of that sphere along this red line has to be same. Total velocity need not be same. Total speed need not be same. I don't care about total, but the component along the normal must be same. If we take two spheres, then the common normal is the line joining the centers. Have a look at this page. There, that is the main theme of rigid body constraints. In case of a string, the length of the string is constant. That was the main idea we played around. In case of rigid body constraint, the body cannot compress, cannot elongate. So if you take any 2 points on the body, and if you take the velocities along the line joining, they must be same. Any doubts on this? Please ask. Clear? Venkatesh, clear with this? Neil, clear, na? Udayan, clear? Ronak, got this? Rehan, Vartika, Anusha, clear, na? Aryan, Abhinav, go ahead.
Yeah.
Going ahead, let's see a problem on this. So we have two walls. Standard problem, not exactly a standard one. We will modify that a bit. So we have a rod here, length L. There is a point A here, and there is a point B here. There is a point C here, and there is a point D here. C is the center of the rod. D is some random point on the rod. Let this distance be small d. Right? So D is some point on the rod. A to D, the distance is D. Now someone is pulling this point A with a constant speed U. Is pulled horizontally with speed U, and B is always in contact with the wall. B won't fly away. Now, exam they won't mention that, because you guys are getting weird ideas. I'm telling you that. So be careful. Exam you can't argue like, "Arey, aisa kaisa hoga?" They'll just give you -1. They don't care. Especially mains exams, you can't argue only. They give any shit. Advanced mein, fir bhi you can argue. Now, what are the questions? First one. This is a standard question. Find VB. Second thing, find acceleration of B. Third question, find velocity of C. I think I'll just add that only, velocity of B and velocity of C. Third, find the equation of the path, or find the path in which C and D will travel. Find equation of the path C and D travel. Find the equation of the path followed by C and D. In exam, they would ask you like, what is the path of D? Straight line, circle, parabola, hyperbola, ellipse. Options will be there. Let's get this thing. Find VB is a pretty standard question. Remaining all are something different. Get them all. You got 4 minutes. First, let's get VB and BC. Okay. Do the rest. I'm more interested in VC. V भी तो आ जाएगा सबको. And you must have done in your classes also. That VC, acceleration of B, and the equation of the path. Those three questions are added. That is the best part. Physics, right? We need not do new things. You take that standard question and you can make a mess out of it. That's how you learn. Don't try to do 10 different things. You take one or two problems, which you already know, and just try to play around, try to put more variables, try to change more. Think. Give it a try. Just give it a try. I'll get some water and come. Let's see, VB, velocity of B and acceleration will be same. Nahi re. How can velocity and acceleration be same? First part, everyone. This is a rod. This is A. This is B. So this is the line joining along AB. This A guy is going this way. The B guy is going down. This angle is theta. This angle is theta. This angle is 90 minus theta. So take the component. So component along the line, this will be VA cos theta. And this component would be VB cos 90 minus theta. So from the rigid body constraint, velocity along the line joining should be same. So VB cos 90 minus theta becomes sin theta is equal to VA cos theta. So we get VB is equal to U cot theta. That's your first part. U tan theta, no re, how can it be U tan theta? Check your calculation where you goofed up. You take the BC, B is always in contact with the wall. Matlab B is coming down. कोई दूसरा option ही नहीं है. B has to slide down. So B ka velocity along the rod and A ka velocity along the rod should be equal. I think some of you did this. You wrote tan theta is equal to VB by VA. Don't do that. That's a blunder. Tan theta is opposite side ka length by adjacent side ka length. That is length, not velocity. But you can say, sir, but in kinematics, in vectors, we used it. That is velocity of a particle. That's the velocity of one particle, Vy and Vx. Tan theta is Vy by Vx. Again, listen to this thing. The goof up you did. Velocity of a particle, tan theta is Vy by Vx. Here, you are writing B ka velocity, A ka velocity. Two different particles you're talking about. You can't write tan theta is Vy by Vx for this guy. I hope you're getting the difference. If Vy and Vx are velocities of a particle, same particle, then you can write tan theta as Vy by Vx. What to do for the acceleration? We have done last time, remember? Differentiate. And when you differentiate, what happens? Theta is variable. This will become acceleration of B. This will become U, cot ka differential minus cosecant square theta, d theta by dt, plus cot theta, du by dt. U is anyway constant, so this term is 0. I need to find d theta by dt. How do I get that? This is theta, this is length L, this is x. So cos theta is equal to x by L, differentiate, minus sin theta d theta by dt is equal to 1 by L dx by dt. X is changing because of velocity of A, so that is VA by L. So we get d theta by dt is equal to minus u by L sin theta. Take that and substitute here. We get acceleration of B is equal to minus u cosecant square theta. I'll just write that as sine square theta, and d theta by dt is minus u by L sin theta. So we get acceleration of B is equal to u square by L sin cube theta. Check, that's your acceleration of B. If theta is changing, you have to differentiate and you'll get d theta by dt. A is going with constant speed, not B. Angle is changing. Please check this out. We have done something like this last time. Again, remember, we have derived, velocity along the thing is 0. That need not be true for acceleration. You defined everything for velocities only. If the theta is not changing, then V and A will work. But if theta is changing, that V correlation is not true for acceleration correlation. Please check out this page. It's a good one. I can just ask you acceleration, it will become an advanced question. If I just ask you find VB, that will be a bits ka easy question or mains ka easy question.
So VB we can find using differentiation also, right?
कर सकते हो, but why to bring so much differentiation? Again, you're using length of the thing is constant. You could have done that. Should have got it. X square plus y square is L square from there you'll get it. Clear with this? Question C. Velocity of C. अभी तक वो हुआ नहीं. How to find velocity of C? Try. Find velocity of C and the path followed by C and D. Everyone can have a look at this page. Any doubts on this page? Ask. Others, you continue doing velocity of C. I will show the question in a minute, but this page should be clear for everyone. Anyone not convinced, please ask. Any step you're not clear? Clear, na? All clear with this page, right? Perfect. Get this question remaining to velocity of C u by 2 cot theta. नहीं Ronak, that is wrong. I cap j cap में आएगा. Find the velocity of C and find the path of C and D. This, if I ask you the path of C and D, this will become advanced paragraph question. Pretty good one. Other than VB remaining 3, right? I can ask anyone. It will be a proper advanced multiple choice question or a paragraph. Or even better, I can ask in a matrix matching. Think. I'll give 2-3 minutes. It is worth time spending. It's worth spending that time. See, you might be right, Anika. No, you're wrong. Incomplete answer. Tha. Listen to this thing. So this is point A. Let the coordinate be x, 0. This is point B, the coordinate 0, y. This is point C, the coordinate would be x by 2, y by 2, the midpoint. That means the position vector of C would be x by 2 I cap plus y by 2 j cap. You want velocity of C? Differentiate. drc by dt would be velocity of C. That would be half dx by dt I cap, half dy by dt j cap. You get it from coordinates. And what is dx by dt? Velocity of A. What is dy by dt? Velocity of B. A का velocity is u by 2 I cap. And B का velocity u cot theta down na, so minus u cot theta by 2 j cap. Check. And from here you can clearly see the x and y coordinate, right? So xc is x by 2, y coordinate of C is y by 2. If you do xc square, xc is the x coordinate of C, that's the meaning of it. Plus yc square will be x square plus y square by 4, which is nothing but L square by 4 or L by 2 whole square. This is the equation of a circle. If you write x square plus y square is equal to r square, r is the radius of the circle. That means this point C is rotating about the origin in a circle, meaning, and it won't go a full circle because the walls are blocking it. It will go in a circle of radius L by 2. So the path of C is a circle of radius L by 2, whose center is the origin. Check. Now, can you do the same thing for D? I think now you got the hint. Kaisa karna hai, D ka path. Find the coordinates of D. D is at a distance D from A. D ka path will be nice. So x square plus y square is equal to r square is a circle ka equation. There's actually a more general equation, x minus h whole square plus y minus k whole square is equal to r square. That Max will teach you. But for now, this much is sufficient for us. That point C always goes in a circle. Find the coordinates of D and try to figure out from there what is the path of D. Anyone who's not clear with this, please ask. Venkatesh, Mehan, keep your cams on. Any ideas? So assume A ka coordinate is x and B ka coordinate y. From there you find D ka coordinates. Try. I'll give you a minute. Anyone got it? No? Just a geometry there. This is x comma 0. If you take this point as D, this is theta. This is D. So this would be D cos theta. This would be D sine theta. So x coordinate of D will be x minus D cos theta. And y coordinate of D will be D sine theta. So yeah. No, x minus d cos theta. Actually, I can find the x also, no? This whole length is L. So this x is actually L cos theta. So this would be L cos theta minus d cos theta. So xd by L minus d would be cos theta, and yd by d will be sin theta. Square them and add them. We get xd square by L minus d whole square plus yd square by d square is equal to 1. Now, this is L cos theta. You should have an idea about this. This is an equation of an ellipse. So the equation of an ellipse is given by x square plus a square plus y square by b square. In the booklet that I gave you, there's a section with all graphs. This is an ellipse where this length is 2a, this length is 2b. This is called minor axis, the smaller one. The 2a is called major axis. So any equation of this form is an ellipse. If a is equal to b, it becomes a circle. So the path of d is actually an ellipse. So d is going in an elliptical path. Now this thing you should know. But I think if you got till here, I think you did a good job. I can understand if you don't know it's an ellipse. That you will learn anyways. So if you observe on the rod, we have 3 different paths. A and B are going in a straight line. C is going in a circle. Every other point is going in an ellipse. Isn't it? D is any random point on the rod. This is an ellipse for one condition. For D not equal to 0, L by 2 and L. Because if D is 0 or L, it becomes a and B straight line. If D is L by 2, it becomes a circle. Any other point other than these 3, every point on the rod will go in an ellipse. Check this out. All clear with this? It's a good one. Make sure to try this again on your own. You want to try this something for more fun, you can think of something of this sort. Put an incline like this. That's what I'm saying. You need not actually go and jump into 100 books. You can take an incline like this. This is theta. Let's say this angle is 120. A is being pushed horizontally. This is B. This is C. Now you can play around. Find velocity of B, find velocity of C. You can try this as a homework. Just make the instead of a 90 degrees, if you just make this thing, it is gone. Won't y be L sin theta? Why it will be L sin theta minus d, right? Height is this only enough from the ground level. Why are you trying to find this height? Y coordinate is measured from the ground level, right? All clear with this? Good one. I'm sure you also seen this problem, no? But in that thing, you must have found only velocity of B. You can make it this deadly. Next one. Any doubts on this question? Anything you're not convinced, please ask. Let's see the next one. We have a wedge here. We have a sphere. This is A and this is B and this is theta. So someone is pulling B with a constant speed U. Find V. So the ball A, the sphere, is stuck between the wedge and the wall. As you're pulling it out, the ball will slide. This is an easy version. We'll do a better version of this in the next one, B part. Get this, find velocity of B. Sorry, velocity of B, yeah. B is pulled left with a speed u. Actually वो constant होने का जरूरत नहीं है. Get this, easy one. You got a minute. Better question is this. The B part is an actual question. The ball is stuck between two wedges and both the wedges are going in both the directions, U and to U. U cos theta j cap. Someone got U tan theta j cap. I think it should be tan theta, Anika. Check it out. The first was easy. Remember what it said, whenever you have two bodies here, this is the common normal. Velocity along the normal should be same. So this point A is going this way. This point B is going downward. If this is theta, this is 90 minus theta. So this would be 90 minus theta. And if that is 90 minus theta, this is theta. So components of B along this red line will be VB cos theta. The component of VA along the red line will be VA cos 90 minus theta. This was the statement we wrote. Velocity along the normal should be same. So VA sin theta should be equal to VB cos theta. VA is U, tan theta is VB. Check, that's your answer. And luckily here, if you want acceleration, if you differentiate, you get actually acceleration of A, tan theta is acceleration of B. Theta is constant here. So you can do this for acceleration or velocity, it works. Theta is the angle of the incline that will never change. You have a problem nahi tha. If you wanted acceleration, you would have got that also. Check this. I hope you got the idea here what we did. Draw the common normal and take the velocity along that normal should be same. All clear with this method? Do the B part. The B part is the actual problem.
Sir, could you show the last slide?
Anyone not convinced with this? Any confusion, please ask. The test will be online till Tuesday night 11 o'clock, so make sure to give it. Next question, yeah. We have two wedges A and C, identical wedges theta theta. U by sin theta minus cos. नहीं आ देते, you'll get answer I cap j cap में आएगा. The A is going left with U, C is going right with 2U. There are two ways to do this. I'll show you both the methods. How to do this thing? Let me show you the first method. The problem is what both the wedges are moving. That's your problem now. Stop one of them. Solve with respect to C. The moment you stop C, means you're keeping the observer on C. And if you ask him what is happening, you know what he will say? He will say, okay, I'm at rest. Now this guy A is going with 3U, isn't it? Relative velocity, na? 2U, so opposite to U, 2U. So C will think A is going with 3U. And this whole question becomes like the first problem. This looks similar to B part, A part. So if A is going with 3U, this we just now related VB will be equal to VA tan theta. So we get velocity of B as seen by C will be minus 3U tan theta j cap. So this observer will think B is going down with 3U tan theta j cap. But what I want is velocity in the ground frame. So velocity of B in the ground frame is velocity of B in the frame of C plus velocity of C in the ground frame. So that would be minus 3U tan theta j cap. And C itself is going with 2U I cap. That's your answer. If you just stop C and see the problem, it looks exactly like part 1. This becomes like a wall, not moving. Then it looks like A is going with 3U and the ball is simply sliding down. But in reality में ऐसा नहीं हो रहा है. Reality में the ball is going this way also and is going this way also. So using relative motion, you get the answer quite fast. Do check out the method. Because the moment you stop C, the ball B is in contact with C, it has to slide along vertically. So we can use partaker result. But some cases, right, relative velocity doesn't help at all. We will see a case like that. So then क्या करना है? So let me show you this in another way, which is more complex, but that will be a more general method. Any doubts on this part? First ask. Clear? Anyone not convinced with this? Not clear? Please ask. Clear, na? Rehan, Niranjan, Anika, clear? Rehan, Aryan, Yasha, clear, na? Now, the alternate way. This is more generalized method. Since we don't know how B is going, let the velocity of B be Vx I cap and Vy j cap. This is the thing. Whenever you don't know how it is going, always assume two velocities. So this is what we do. So we assume this is going with Vx and this is going with Vy. Now, if you observe, there are two normals here. This is a normal because you're in contact with B and C. This is another normal. Now, from the rigid body constraint, velocity along the normal has to be same. So first, let's take B and C. B and C. I know C is going this way with 2u. And I know B is going this way with Vx. So along the normal, the velocity has to be same. Velocity along normal must be same. So Vx is equal to 2u. Make sense? Now take the other guy. This is a little goofed up. This is your normal. This is Va, that is u. This is theta. This is 90 minus theta. So this is also 90 minus theta. This is your Vx. This is your Vy. This should be 90 minus theta. This is theta. So Vx and Vy ka component along the red line should be same. So this would be Vy cos theta minus Vx cos 90 minus theta, because Vy, Vx both belong to the same body. So Vy ka component, Vx ka component in this direction should be equal to the du ka component, which is u cos 90 minus theta. So this would be Vy cos theta, and Vx I know is 2u sin theta is equal to u sin theta. So I get Vy is equal to 3u tan theta. There. So basically, how to write the velocity along the normal of A and B and C equal. Two equations aayega, two unknowns. That's how we get Vx and Vy. This is how you do generally these kind of questions. But luckily here, if you stop C, it looks like a part one and life becomes easy. Let me show you a question where it is the relative motion thing really doesn't help. But this is how you generally solve any question. There we got the answer. Now Vx is 2u and Vy is downward. I showed 3u tan theta down. Clear? All got this thing? So let's see a question based on this. Anyone not clear with this, please ask. So basically the main idea is, since you're touching 2 points, if suppose there are three bodies now, you have to write three normals. That would be more messed up, but let's see. Let's have two edges like this. This is A, this is B, this is C. This angle is 37 degree. This angle is 45 degree. This guy VC is going with 10 meter per second. This guy VA is going with 5 meter per second. Yeah, find VB. So basically B now is like this, it is sliding on both of them. I hope the diagram was clear. So B kind of looks like this. This is B. So both the sides, it is just sliding on the two surfaces from both the sides. And यहाँ पे by stopping one of the body, you really don't get an advantage because the B will go like this then. You could do, but let's do this Vx, Vy stuff. Since you don't know how B is going, assume Vx, Vy, two normals. Just to give an idea, this is one normal and this is one normal. Let's get this. Just get the equation, meaning numbers will be a little bad, but try. You got a minute or two. So there are two surfaces in contact. I'll just give them some space like this. So this is the normal. This angle is 45. So VC is going this way with 10 meter per second. So this is also 45. This is Vx and this is Vy. Luckily 45, no? So this will be 45 and that will be 45. So we are writing for B and C first. So if you write along B and C, velocity along the normal Vx cos 45 plus Vy cos 45 should be equal to 10 cos 45. So Vx plus Vy is equal to 10. That's your equation. Now on this side, this is the normal, the green line. This guy is 37 degrees. So if you take this thing, speed is 5. This is 37. So 90, 53. So this is 53. Now here, be careful. Vx is this way. Vy is this way. So this is 53 and this is 37. Again, you should take velocity along the green line. So 5 cos 53 should be equal to Vy ka component is along this thing. So Vy cos 37, but Vx ka velocity is opposite. Vx cos 53. Cos 53 is how much? 3 by 5. So that would be 3. Cos 37 is 4 by 5. Vx cos 53 is 3 by 5. So there, 4 Vy minus 3 Vx is equal to 15. This is your equation 1 and this is your equation 2. Two equations, two unknowns, solve. I guess it's lengthy. There is no other way out actually. You literally have to take the two normals and get the components. So substitute here, we end up with 4 Vy minus 3. 10 minus Vy is 15. 7 Vy, that would be 30 plus 15, 45. So Vy is 40 by 7. Vx would be 70 minus 45, 25 by 7. Hope I'm right. Yeah. Check out this thing. All clear with this? This is lengthy. If you can stop C and do, I'm not sure how that will be. You can do actually, then B will slide along the incline of C and then you have to resolve. But okay, better you remember one standard method like how to figure it out. All clear with this? Turn in the page. Last one for the day. We have a rhombus. Kind of thing. A, B, C, D, and E. This is theta. This length is 5 meters. This length is 3 meters. This length is 2 meters. You know, how is this looking like? It looks like this. Must have seen this in Tom and Jerry and all. Open the box and this thing hits you. So basically, this is a rhombus shaped frame. So if you try to pull B, it will stretch like, these things, rhombus. Can you see how it is expanding? It's a rhombus shaped frame. So someone is catching this point A and it's pulled with constant speed U. Find velocity of B, velocity of C. Homework. Next class we'll discuss the velocity of D and velocity of E. For now we'll do B and C at an angle theta. So when you're stretching the rhombus at a particular angle, so theta is continuously changing there. I could have asked you acceleration also, that would be more fun, but okay, you got the point. Did everyone got the diagram? Meaning next moment, you know how this will look? Next moment, this will become like this. This will become like this, and this will become like this. You're getting it will become thinner. The whole thing is stretching forward and the whole thing becomes thinner. The next moment, it would become kind of like this. I hope you're getting how it is stretching. The rhombus is becoming thinner. Let's get this. Let's find B and C. You guys find D and DN. So there are two homework questions, this one and that one, 120 degrees wala incline. So try these and come. Next class, we'll discuss them first thing in the class. And then we'll start off with laws of motion, free body diagram and stuff. It'll be more theoretical next class, but quite an important class. A lot of theory is there. We'll wrap up laws of motion another 2 weeks. Get this. We see you now. See. I think I don't know what this picture is stuck. Now it is given, it is in the ratio of 3:5:2 now. This is 5 meter, 3 meter, 2 meter. So let's assume this length is 5x. Then this length will be 3. I don't know what is x. This length is 2x. That means this coordinate will be 10x, 0. This coordinate is 8x, 0. And this coordinate is 5x, 0. This is A and this is B and this is C. So velocity of A is how much? Rate of change of the coordinate, which is 10x. And you're saying this is u. That means dx by dt is u by 10. What is velocity of B? Rate of change of coordinate of B, which is 8x, which is 8u by 10, 0.8u. What is velocity of C? Rate of change of x coordinate of C, because ABC will go in a straight line. That would be 0.5. Easy? ABC are actually easy. Now, I don't know what is x, I don't care, but I know they'll be in the ratio of 5,3 to x because the sides are 5,3x, 532. You guys try at home D and D. That will be more better question. Okay, so with that, we are done with constraints also. We are done with rigid body constraints, string constraints, 3 methods. Method 1 and method 3 are kind of actually same. Method 1 is more mathematical, method 3 is more of visualization. Method 2 is quite useful. 90% problems get solved with method 2. But method 3 does come in handy, when there are certain problems which looks pretty, tension method won't be applicable. You can visualize and do it. Rigid body thing you understood. So make sure to go all through this. We did almost 19 problems and you have a sheet. I think the sheet has another 34 problems. So do make sure to finish it off. That should be a good amount of practice for constraints. Generally, I think, PACE booklet, you don't have enough questions on constraints. They must be there or must be scattered. I'm not sure. I don't think you have so much collection, but okay. I'll send you one more sheet, right? Maybe after 1 or 2 days. So do finish off this. And then next week when we catch up, we will do this. So units and dimensions test is online, valid till Tuesday night, 11 o'clock. So make sure to give, don't miss it out. Okay, so those are doubts, stay back and ask, or else you're free to leave. So take care, stay safe.